Introduction to Automobile Engineering 2. Learning Objectives. At the end of this topic, you will be able to explain the types of fuel burnt, define ignition system, describe the battery and magneto ignition system, define firing order, describe the engine construction, explain turbocharging and supercharging, describe engine lubricant system, define oil filter and oil pump, explain crankcase ventilation and engine service. Outcomes. By the end of this topic, you will be able to understand various types of fuel burnt, know about the concept of ignition system, firing order, oil filter and oil pump, understand the battery and magneto ignition system, know about the engine construction, have an idea about the turbocharging and supercharger, understand engine lubricant system, know about crankcase ventilation and engine service. Types of fuel burnt. 4-stroke petrol, SI engine. 2-stroke petrol, SI engine. 4-stroke diesel, CI engine. 2-stroke diesel, CI engine. 4-stroke petrol, SI engine. 4-stroke spark ignition, SI engines require 4 piston strokes to complete one cycle. An air and fuel intake stroke moving outwards from the cylinder head. An inward movement towards the cylinder head, compressing the charge. An outward power stroke and an inward exhaust stroke. 4-stroke petrol SI engine is shown in the figure 1. Induction stroke. Due to the suction created by the motion of the piston, it moves towards the bottom dead center. The charge consisting of air-fuel mixture is drawn into the cylinder. When the piston reaches the BDC, the suction stroke ends and the inlet valve closes instantaneously. Compression stroke. Both the inlet and exhaust valves are closed. The piston moves upwards. The charge is progressively compressed to 1/8 to 1/10 of the original volume, increasing the charge pressure and temperature. Power stroke. Both the inlet and the exhaust valves are closed. Just before the piston reaches the TDC during the compression stroke, a spark plug ignites the charge. When the piston reaches the TDC, the charge begins to burn, rapidly raising the pressure and temperature and forcing the piston to move downwards in the power stroke. Exhaust stroke. At the end of the expansion stroke, the exhaust valve opens instantaneously and the inlet valve remains closed. The pressure falls to atmospheric level. A part of the burnt gas escapes. And then the piston starts moving from the bottom dead center to top dead center and sweeps the burnt gases out from the cylinder almost at atmospheric pressure. 2-stroke petrol SI engine. The 2-stroke spark ignition SI engine completes the cycle of events, induction, compression, power, and exhaust in one revolution of the crankshaft or 2 complete piston strokes. 2-stroke petrol SI engine is shown in the figure 2. 1. Induction and exhaust stroke. The piston moves down the cylinder and initially uncovers the exhaust port, E, releasing the burnt gases to the atmosphere. Such a movement also compresses the charge in the crankcase. Further movement of the piston uncovers the transfer port T, allowing the compressed mixture to be transferred to the inside of the cylinder, pushing out any remaining of the burnt gases. 2. Compression and power stroke. The piston moves in the direction of the cylinder head, sealing off all ports and compressing the mixture. Further movement of the piston increases the volume in the crankcase, creating suction. So when the inlet port is uncovered, fresh charge is sucked into the crankcase. Just before reaching the TDC, a spark plug ignites the compressed mixture, raising the pressure and temperature of the mixture very rapidly. The burnt gases expand, forcing the piston to move down the cylinder. 4-stroke diesel engine. It is just like the 4-stroke cycle petrol engine. The compression ignition CI engine completes one cycle of events in 2 crankshaft revolutions of 4 piston strokes. The 4 phases of these strokes are shown in the figure 3. Induction of fresh air. compression and heating of this air, injection of fuel and its burning and expansion, and expulsion of the products of combustion. Induction stroke. Atmospheric air alone is inducted through the suction stroke. During this stroke, the inlet valve is opened and the exhaust valve is closed. Compression stroke. Air inducted during the suction stroke is compressed into the cylinder. Now, both the valves remain closed during this stroke. Power stroke. Fuel injection starts nearly at the end of the compression stroke. After the injection of fuel is completed, the products of combustion expand, so that both the valves remain closed during this stroke. Exhaust stroke. When the piston travels from BDC to TDC, it pushes out the products of combustion. The exhaust valve is open and the intake valve is closed during this stroke. Two-stroke diesel CI engine. The piston moves away from the cylinder head, and when it is halfway down its power stroke, the exhaust valves open, allowing the burnt gases to escape through the exhaust valves. When the piston moves down near the end of the power stroke, the inlet ports are uncovered, allowing fresh air from the blower to be admitted. The piston moves upward towards the cylinder head, sealing off the inlet ports and helping the fresh air to push any remaining burnt gases through the exhaust valves, and the exhaust valve closes. The piston continues to move upward, compressing the charge of air and raising the temperature and the pressure to about 30 to 40 bars. Before the piston reaches the TDC, fuel is injected into the charge. The heating charge vaporizes the fuel and ignites it. The rapidly burning mixture raises the pressure and temperature very rapidly inside the cylinder and forces the piston to move away from the cylinder head in the power stroke. Ignition system. Ignition system for SI engines. An ignition system for SI engines must fulfill the following basic requirements. 1. A source of electrical energy. 2. A means of transforming the low voltage from the source to a very high potential required to produce a high tension across the spark to ignite the combustible mixture. 3. A means to distribute the high potential to each spark plug at the exact instant it is required at every cycle and for cylinder. The basic source of the electrical energy may be either a battery, a generator, or magneto. There are two basic ignition systems that are generally used. They are battery ignition system, magneto ignition system. Battery ignition system. It mainly consists of 6 or 12 volts battery, ammeter, ignition switch, auto transformer, step-up transformer, contact breaker, capacitor, distributor rotor, distributor contact points, spark plugs, etc. The ignition system is divided into two circuits. Primary circuit. It consists of 6 to 12 volt battery, ammeter, ignition switch, primary winding. It has 200 to 300 turns of 20 SWG, standard wire gauge, gauge wire, contact breaker, capacitor. Secondary circuit. It consists of secondary winding. Secondary ignition systems winding consists of about 21,000 turns of 40 SWG gauge wire, bottom end of which is connected to the bottom end of primary and top end of secondary winding is connected to the center of the distributor rotor. Distributor rotors rotate and make contacts with contact points and are connected to spark plugs which are fitted in the cylinder heads. Working. When the ignition switch is closed and the engine is cranked, as soon as the contact breaker closes, a low voltage current will flow through the primary winding. It is also to be noted that the contact breaker cam opens and closes the circuit 4 times for 4 cylinders in 1 revolution. When the contact breaker opens the contact, the magnetic field begins to collapse. Because of this collapsing magnetic field, current will be induced in the secondary winding. And because of more turns, at 21,000 turns of secondary voltage goes up to 28,000 to 30,000 volts. Magneto ignition system. In this case, magneto will produce and supply the required current to the primary winding. In this case, as shown, We can have rotating magneto with fixed coil or rotating coil with fixed magneto for producing and supplying current to primary. Remaining arrangement is the same as that of a battery ignition. On each revolution, a cam opens the contact breaker one or more times, interrupting the current, which causes the electromagnetic field in the primary coil to collapse. As the field collapses, there is a voltage induced, as described by Faraday's law, across the primary coil, as the points open. Comparison between battery and magneto ignition system. Battery ignition. Battery is a must. Battery supplies current in primary circuit. A good spark is available at low speed too. Occupies more space. Recharging is a must in case battery gets discharged. Mostly employed in car and bus, for which it is required to crank the engine. Battery maintenance is required. Magneto ignition. No battery needed. Magneto produces the required current for primary circuit. During starting, the quality of spark is poor due to slow speed. Very much compact. No such arrangement required. Used on motorcycles, scooters, etc. No battery maintenance problems. Firing order. The order in which various cylinders of a multi-cylinder engine fire is called the firing order. The number of possibilities of firing order depends upon the number of cylinders and throws of the crankshaft. It is desirable to have the power impulses equally spaced, and from the point of view of balancing, this has led to certain conventional arrangements of crankshaft throws. In case of SI engines, the distributor connects the spark plugs of different cylinders according to engine firing order. Advantages. A. A proper firing order reduces engine vibrations. B. Maintains engine balancing. C. Secures an even flow of power. Firing order differs from engine to engine. Probable firing orders for different engines are 3 cylinders is equal to 1, 3, 2. 4-cylinder engine inline, that's equal to 1, 3, 4, 2. 4-cylinder horizontal opposed engine equal to 1, 4, 3, 2. 6-cylinder inline engine 1, 6, 5, 4, 3, 2. 8-cylinder inline engine 1, 6, 2, 5, 8, 3, 7, 4. 8-cylinder V-type 1, 5, 4, 8, 6, 3, 7, 2. Engine construction. Inside the solid body of the engine, there are a number of fast-moving and stationary parts. They are 1. Main moving parts. Piston and piston rings, connecting rod, camshaft, valves and valve springs, crankshaft, flywheel, etc. 2. Stationary parts. Cylinder block and head, timing case, fuel injector. Main moving parts. Piston. It is considered as the heart of the engine, whose main function is to transmit the force exerted by the burning of charge to the connecting rod. The pistons are generally made of aluminium alloys, which are light in weight. They have good heat conducting property and also great strength at high temperatures. Piston rings. Piston rings can be divided into 2 groups. Compression rings, whose function is to seal the space between the piston and the cylinder wall so that gas cannot escape. Oil control rings, whose main purpose is to control the amount of lubricant passing up to the top of the cylinder walls. Compression ring action. The piston ring is designed to expand radially outward when fitted in its groove, so the ring will tend to spring outwards to apply pressure on the cylinder wall. On the upward compression stroke, the compressed charge will move between the groove and the ring side faces, press the ring against the lower groove of the piston. This provides a very effective compression seal without leakage. On the downward power stroke, piston acceleration is greater than that of the ring. so that the upper groove and the ring side faces will be held firmly together to form the seal. Oil control ring action. During the crankshaft rotation, oil is splashed from the big end bearing onto the cylinder walls. The oil control scraper ring performs two functions. First, it regulates the amount of oil passing to the combustion chamber, and secondly, it distributes a film of oil over the cylinder surface to lubricate the cylinder walls and the compression rings. On the piston's upward stroke, the lower face of the ring will be held firmly against the lower groove, so that the upper face of the ring will scrape a proportion of the oil. The excess oil will accumulate in the clearance space of the groove until it overflows through the drillings to the sump. On the piston downward movement, the ring will snap over to the top of the ring groove. The sharp edge of the working face of the ring will scrape the oil down the cylinder wall. The surplus oil accumulates in the space of the groove and overflows through the drillings. Connecting rod. The connecting rods are forged steel rods that connect the piston to the crankshaft. They transfer the force from the piston to the crankshaft. Each connecting rod is connected to a piston by a piston pin. Gudgeon pin. A pin holding a piston rod and a connecting rod together. Camshaft. A camshaft is a shaft to which a cam is fastened, or of which a cam forms an integral part. The camshaft is driven by the crankshaft through timing gears. Valve. A valve is a device that regulates, directs, or controls the flow of a fluid, gases, liquids, fluidized solids, or slurries by opening, closing, or partially obstructing various passageways. They provided either on the cylinder head or in the side of the cylinder for regulating the charge coming into the cylinder, inlet valve, and for discharging the products of combustion, exhaust valve, from the cylinder. Valve spring. Any spring that closes a valve after it has been opened mechanically or by the flow pressure. Crankshaft. It is considered as the backbone of an engine whose function is to convert the reciprocating motion of the piston into the rotary motion with the help of a connecting rod. The shaft contains one or more eccentric portions called cranks. That part of the crank to which bigger end of the connecting rod is fitted is called a crank pin. The following figure shows the various engine components. Flywheel. The flywheel performs several functions for an engine. First, it acts as a balancing weight for the crankshaft. As the crankshaft turns, the flywheel also spins. The spinning weight of the flywheel helps to balance the jerking and pulsating motions of the crankshaft as it rotates with each power stroke. This helps keep the crankshaft turning smoothly between the power strokes. In addition, the weight of a heavier flywheel will serve to keep the crankshaft in motion, improving engine performance and efficiency. Stationary parts. Cylinder head. The cylinder head sits on the top of the block, which makes the space inside the cylinder airtight. It also carries the fuel injector, valves, and the exhaust and inlet passages. Engine block. Engine block is a large, strong piece of metal that is the main structural member of the engine. It is the collective term that refers to the crankcase and all the components that fill it, including gaskets, valves, seals, etc. The core of the engine block is the cylinder, capped by the cylinder head. The number of cylinders determines the size and placement of the block. Fuel injector. A device for actively injecting fuel into an internal combustion engine by directly forcing the liquid fuel into the combustion chamber at an appropriate point in the piston cycle. Performance of quick and complete combustion is ensured by a well-designed fuel injector. By atomizing the fuel into very fine droplets, it increases the surface area of the fuel droplets, resulting in better mixing and subsequent combustion. The primary difference between carburetors and fuel injection is that fuel injection atomizes the fuel by forcibly pumping it through a small nozzle under high pressure, while a carburetor relies on suction created by intake air accelerated through a venturi tube to draw the fuel into the airstream. Turbocharging. These equipments are used to compress the air being delivered to an engine, allowing the combustion chamber to be overfilled without enlarging the space. The higher concentration of oxygen provided by a supercharger is matched with a larger amount of fuel from the fuel injectors, thus boosting the power of the engine. Advantages: increases the power of an engine. Efficient working supercharger can achieve the same speed in 1/3 of the time. Necessary in aeroplanes as they have less oxygen at high altitudes. Ensures complete combustion of the fuel. Reduces pollution to some extent. Principle of working: more fuel plus more air is equal to bigger explosion. That's equal to greater horsepower. Turbocharger. Turbochargers are centrifugal compressors driven by exhaust gas turbines. By utilizing the exhaust gas energy of the engine, it recovers a substantial part of the energy that would otherwise go waste. Thus, turbocharger will not draw upon the engine power. Supercharger. A supercharger is a mechanically driven blower that forces air into the engine cylinders under pressure. Engine lubrication. Lubrication is essential to reduce friction and wear between the components in an engine. This includes the friction between the piston, cylinder wall, etc. Functions of a lubricating system. The engine lubricating system supplies oil to all moving parts. The oil pump picks up the oil from the oil pan and sends it up through the oil passages to the main bearings of the crankshaft. Oil from the main bearings moves through the oil holes drilled in the crankshaft to the rod bearings. Oil then passes through an oil line to the cylinder head, where it flows through an oil gallery to camshaft bearings and valve train parts. The pistons, piston rings, and piston pins receive oil thrown off the connecting rod bearings. This oil falls on the cylinder walls, thereby reaching the pistons, rings, and pins. Then the oil drops back down to the oil pan. Types of lubricating system. Splash lubricating system. In the splash lubricating system, oil is splashed up from the oil pan or oil trays in the lower part of the crankcase. The oil is thrown upwards as droplets of fine mist and provides adequate lubrication to valve mechanisms, piston pins, cylinder walls, and piston rings. In the engine, dippers on the connecting rod bearing caps enter the oil pan with each crankshaft revolution to produce the oil splash. A passage is drilled in each connecting rod from the dipper to the bearing to ensure lubrication. The splash system is no longer used in automotive engines. It is widely used in small 4-cycle engines for lawnmowers, outboard marine operation, etc. Disadvantages. The energy required to splash the lubricating oil is not fully utilized to lubricate the engine parts. Most of the engine energy is lost in splashing the oil over the interior of the crankcase, and the oil returns to the sump without lubricating the parts. Pressure lubrication system. Modern vehicle engines use a pressure lubrication system where the oil is forced around the engine under pressure. Oil pump collects it through a pickup tube and a strainer and forces it through an oil filter and then into passageways in the engine block called galleries. The galleries allow oil to be fed to the camshaft bearings, the valve mechanism, and the crankshaft main bearings. Holes are drilled in the crankshaft webs, allowing the main bearings to supply oil to the big end bearings. After circulating through the engine, the oil falls back to the sump to cool. Pressure lubrication system. Wet sump lubrication system. In wet sump lubrication system, the bottom of the crankcase contains oil sump that serves as the oil reservoir. Oil dripping from the cylinders and bearings flows by gravity back into the wet sump. From oil sump, oil is picked up by a pump and is circulated through the engine lubricating systems. Advantages. A wet sump offers the advantage of a simple design, using a single pump and no external reservoir. Disadvantages. An internal oil pump is generally more difficult to replace, but that is dependent on the engine design. Dry sump lubrication system. In a dry sump system, the oil falls to the bottom of the engine into an oil collection pan. A scavenge pump then pumps it to an oil tank where it is stored until the normal oil pump collects it and pumps it through the filter and engine in the normal way. Because there is no oil storage sump under the engine can be mounted much lower than in a wet sump system. Advantages. The external reservoir can also be relocated to another part of the vehicle to improve weight distribution. Disadvantages. Dry sump systems add cost and complexity. The extra pumps and lines require additional oil, causing maintenance costs to rise accordingly. Oil filters. Used to trap all solid impurities suspended in the oil before it enters the oil pump circuit from the oil sump. Oil filters are defined into two types. They are 1. Cartridge-type oil filter, in which oil seeps through the filtering element, which traps all the impurities and solid particles. 2. Centrifugal-type oil filter. Impurities are present in the oil, separated by centrifugal action. Main parts are body, rotor, drive chamber. Oil pump. Gear pump. Gear 1 and Gear 2 mesh each other. One of the gear driven by the crankshaft or camshaft. Other is driven by the driving gear. Inlet and outlet of lubricating oil to the pump are located on either side of the meeting point of the gears. The profile of the gear teeth converges at the inlet and diverges at the outlet. With the above arrangement, oil is sucked under pressure on the inlet side and delivered through the outlet on the other side. Crankcase ventilation. Provides continuous ventilation as long as the engine is running. Intake manifold and crankcase is connected under suction pressure. The vapors from the crankcase are constantly scavenged and led into the manifold by suction pressure. Engine service. Reboring. It is a repair process done on worn-out engine cylinders. Steps involved in reboring. The worn-out cylinder bore is slightly enlarged to a circular shape uniformly on all the cylinders in the engine. The reboring should be carried out on the cylinder bore without the cylinder liners. After a cylinder is rebored, oversized pistons and rings must be fitted. Decarburization. Due to the improper combustion of the hydrocarbon, fuels leave liquid and solid hydrocarbons at various levels of decomposition and chemical reaction inside the engine cylinders. They collect thick black deposits on the cylinder walls, piston grooves, and rings. It reduces the clearance space in the cylinders and also influences the performance of the engine. These deposits are cleaned and removed at regular intervals. Kerosene is used to flush out these deposits from inside nitriding of crankshaft. The nitriding process is done in an oven. The cranks are suspended in a closed chamber, which is lowered into the furnace for heating. At a determined temperature, ammonia and nitrogen gas are introduced into the chamber and circulated all around the cranks and the chamber. This heated gas reacts with the carbon on the surface of the crank at a depth of approximately 2 to 3 millimeters, making the surface hard. Summary. Let's summarize. 4-stroke spark ignition SI engines require 4 piston strokes to complete one cycle. The 2-stroke spark ignition SI engine completes the cycle of events: induction, compression, power, and exhaust in one revolution of the crankshaft or 2 complete piston strokes. The compression ignition CI engine completes one cycle of events in 2 crankshaft revolutions or 4 piston strokes. 2 basic ignition systems that are generally used are battery ignition system, Magneto ignition system.